Hello everyone, my name is K. Anish and a very warm welcome to you to this course EE100, and this is specifically based on NIT Goa curriculum. Myself, I am Anish and I completed my first year in NIT Goa. Now I'm studying in BITS Pilani Goa campus, and general instructions for this particular course is that in NIT Goa specifically, I mean in any other college also, this is the general way how things go, is that there are minors, there are midsems, and there are end sems. In NIT Goa, there are three minors, one midsem, and one end sem. So books to follow. I'm specifically following, and this is also recommended for all the first years in NIT Goa. The book Fundamentals of Electric Circuits by Sadiku, and this course requires a lot of practice to get adjusted to the concepts because there are a lot of things that are new to you. This is not the same curriculum that you have studied in your JE. There are a lot of different things to understand. And how to practice is that there are in-text problems. For example, there are examples, there are questions after every chapter in the book Sadiku, and the solution to every odd problem is given at the back of the textbook. So what I'm going to do is I'm going to solve the even problems in my videos, and the or if you want, I'll give you the odd problem solution set also. I will write down the solutions for every question and I will give you in the PDF format, so you guys can cross verify. And one thing to make sure is that there is a very good possibility that there may be some calculation mistakes or final answer may vary with what you are calculating when you are trying out the problem for yourself, because I may make some calculation mistakes, but the underlying concept will be rigid. I can guarantee you that. And why who am I to make this course is I I scored an S grade in my course at EE100, and I scored full marks in all the minors, and score of 87 in my NSEM. That was the highest in my year. So I think yeah. So why I'm making this particular course is that by the end of the year, during my NSEMs, while I was studying for preparing for my NSEMs, when I knew all the syllabus thoroughly, I felt that this course could have been taught to me in a very simplified manner. That I could have learned things in a much more crisp and concise way, and that there was no need for such uh, tedious teaching, tedious methods of learning or whatever. So I want to keep things very short and crisp so that you can watch these videos the day before your exams, or like when you are revising to prepare for your exams. So this is going to help you a lot. So how to make use of these videos? I'm gonna make first the lecture videos. So I'm gonna cover the lecture. These are my handwritten notes. I will give you my handwritten notes, and I will explain to you the lecture in a 30 minutes or 40 minutes kind of lecture. And you guys can watch it on 1.5x or 2x. I have to repeat. I have to say it very slowly because I've not prepared any script for this particular course, and also that some people may find it difficult if I speak in a fast manner. Yeah. So yeah, first I will make the lecture recordings, and then second will be solving. So I'm gonna solve, like I said, the even set of problems, and I will give you the solution for every problem. Now, suggestions and tips for W100 and ITG students only specifically is that you have to attend the. This is not a substitute for classes. You have to attend the classes very thoroughly. You have to understand the concepts there. All this is made solely for the purpose of helping you revise or understand in a very quickly. But this is not a substitute for classes, because what the teachers have a lot of knowledge because they are the experts in their field, and I'm just a like student who has covered. I was just done this course, so honestly I'm not. I can't give you all the knowledge that they can provide you. So this is not a substitute for classes, but I can help you gain marks in this course. I can help you if you do this, whatever I tell you thoroughly. then I can guarantee you without doubt that you will get very good marks and you can get a very good grade. But in the again, the grade is should not be your first priority. Your priority should be understanding the concept, should be solving the problems. The grades will come by on their own, so don't need to worry about that. But I will guide you through everything. If you have any problems, you can contact me through my email, and I will help you through with this course. Yeah. So today we're gonna cover the lecture video for the basic concepts, the first chapter, basic concepts. So you can see here that there are different sections. This is directly a screenshot from the textbook Sadiku. So I'm using that for the basis of my theory. So introduction, systems of units, and you can go through with this. Yeah. So some basic concepts that you already know is that charge of an electron is 1 minus 1.6 into 10 to the power minus 19 coulombs, and number of electrons that make up 1 coulomb is this, right? This is something you already know. Electric circuit. Now, electric circuit is an interconnection of electrical elements. You are very familiar with this. Charge. Charge is a fundamental property of matter. Any body can be classified as neutral, positive, or negatively charged. Electric current. Electric current is a rate of change of charge, which is measured in amps. And you can write this as I is equal to dq by dt. You differentiate it with respect to time, and you, in order to get the charge, you integrate the current with respect to time, right? And units are amps. Electric potential. Now, electric potential. What my professor said, what my lecturer said, uh, the definition. I mean, a very good way to understand this electric potential is that electric potential is a potential is a quantity which you integrate, which you obtain on integrating the particular field. In this case, that is electric field. But you can also understand it in terms of gravitational potential. Like for example, when you integrate the gravitational field, which is g, over a particular length, you get gh, which is the gravitational potential. So this is a very good way to understand. But yeah, work done per unit positive charge, dw by dq, or w by q, to move it across a circuital element. This is very important, because for example, if I consider this circuit, this is simply a loop, right? You cannot yeah, you cannot talk about potential here, because potential is going to be the same at every point, right? You cannot like, there is no point in defining potential in this particular case, because there is no circuital element. So that's why this becomes very important. Now, these are my terminologies. I'm gonna call this mistakes from common practice as MCP. So polarity is very important in case of electric potential. That is VAB is equal to minus VBA. Now this is a very very important concept. Like, you may already know this. Obviously you will know this, but there is a lot of tendency to make mistakes on this particular concept alone. The professor set the question in such a way that the question is pretty lengthy. In once you come to engineering, you will observe the questions become a little lengthier, and you have to calculate a lot of things. And in that process, whenever you are asked to find a potential, you there it is very easy to neglect the sign. I mean, you to forget about the sign. So whenever this is a because I made this particular mistake in my end sim, that instead of writing minus 40 volts, I wrote 40 volts as the answer. Now, let me try to take an example to show you why this is so important. So, consider this electric circuit. So, this is a symbol for a voltage source. I'll explain to you what a voltage source is. Just consider it a battery. So, there is this battery, these are resistors. This is another symbol for resistor. You might be familiar with this symbol, the zigzag symbol. But this is also another way to denote a resistor. This is 2 ohm resistor, this is 4 ohm resistor, this is 3 ohm resistor. Now, I need to find out I need to find out this V. You'll be like, this is so easy. 18 by 2 plus 3 plus 4 times of 4, right? That should be my answer. 8 volts? No. Answer is minus 8 volts. And You can easily tell from this question that, like, you can look at this question and you can like get an idea, okay, but when so many things are asked in a particular question, it is very easy to neglect this particular point. So that's why I'm saying that whenever the question says, it specifies a v across a particular circuital element, instantly think of this particular point. Is the v that it is asking me to find the same v as what I have calculated? This 8 volts was the V that I calculated. That is what, by assuming that, I mean, obviously current is flowing through, like flowing like this, and there's going to be potential drop across this particular resistance. That is, it should be positive here and negative here. I mean, you get the point. But since it is saying that it is negative here and positive here, it means that the V that it is asking us to find out is the negative of the V, is the opposite of the V that I have calculated. This is a very important point. You make a lot of mistakes in this particular point, even after covering like many chapters. You still make so many mistakes in this particular section. Now, Ohm's law: voltage across a device is directly proportional to the current flowing through it. V is equal to IR. Now, mistake from common practice is that people forget that it is valid only for linear circuits. Linear circuits are those where like V is directly proportional to I, right? And this is not applicable in case of transistors, diodes, like their MOSFETs. You will study about this in the electronics section. But yeah, just keep this in mind. That is valid only for linear circuits. Now, resistance is a property of a material to resist the flow of electric current, denoted by R, and units are ohms. Now, this is something that will be new to you. Maybe new to you. I mean, you might have already studied in JE, I guess. But this was new to me. A current source and a voltage source. So what does a current source mean? A current, you see this, let's get familiar with this symbol basically. See this particular circuit. You see this thing, this circuital symbol. So that is a symbol for a current source. What it does is that it maintains constant current through the branch it is present in. What it means is that, say for example, you may already be familiar with KVL, KCL, and all those laws. So if I say, like, assume a V here and I try to find incoming or outgoing currents or something. So the current, regardless of the potential across this particular branch, the current is gonna be 4 amps. So the incoming current would be 4 amps from this side, regardless of whatever the potential you are applying on this side. Good. Now, voltage source. This is the particular symbol for voltage source. Now, battery is also a form of a voltage. There is also an example of voltage source. There are many types of voltage sources, right? So battery is just an example. Now, what is a voltage source? Is that a voltage source maintains a constant potential difference across its two terminals. So you like the battery, for example, it maintains, if I, in this particular example, you see that if I ground this particular point, so obviously this is going to be 5 volts. Or if this is say 10 volts, then it's going to be 15 volts. You get the point. Now, power and energy. So for practical purposes, we need to define one more particular quantity, one more parameter, that is power. Now, power is the rate of change of electrical work. Now, why did we even define this particular parameter? Would you rather buy a 100-watt bulb or 40-watt bulb? You'll say, I mean, you'll say that depends on the necessity, depends on the requirement, depends on the use, right? And that is a very good answer, I would say. But say you had to, consider a hypothetical situation where you don't care about the power loss or how much energy you're utilizing. You just need a bright room. So obviously you will go for a 100-watt bulb, right? So what it means is that 100-watt bulb consumes and supplies more power. That is, it glows brighter. Now, power is equal to dW by dt, d by dt of VQ. Apply chain rule. You get this. From this part, you get VI. Now, we won't be dealing with this in this particular course, this particular term, dV by dt. We won't be dealing with this. I just wrote this to explain how this worked exactly, about how this vi came. Fine. Now power is equal to vi, we got a formula. Okay. Now let's come to another new concept that maybe may or may not be a new concept to you, but to me it was the passive sign convention and active sign convention. So these are, like the name suggests, that these are two sign conventions. Okay. And how it works exactly in passive sign convention, this is majorly used in passive sign convention. The current is entering the positive terminal of the circuital element. The current is entering positive terminal of the current element. Now the formula P is equal to Vi in this particular case gives me the P absorbed, the absorbed power. So for example, let's consider this particular example. uh, Fine. Yeah, let me consider this example. So if vi is equal to positive, then power is absorbed. If vi is equal to negative, power is supplied. I'll show you through this particular example. Now you see this example. There is this current that is exiting from the positive terminal, and I need to find out the power, whether it is supplied by this particular voltage source, or is it whether it's absorbing the power. I want to know. So uh, like active sign convention is basically the opposite of passive sign convention. So since this is majorly used, so I'm going to talk only about this, but you can find out the through the other way by simply reversing the logic. So since the current is leaving the positive terminal, there are two visualizations to solve this particular problem. I can either assume that a minus 3 amps current is flowing into the positive terminal, and then I will write as P absorbed is equal to 4 volts into minus 3 amps is equal to minus 12 watts, right? But like I said, if Vi is negative, the sign will you just follow this particular this concept that reverse the current, or you just follow the visualization. The sign convention will tell you the answer, whether it is supplied or absorbed. You don't need to worry about that. You solve a lot of examples and you will understand. You will This will become like a second brain. Even you can instantly tell the answer. So P absorbed is minus 12 watts, that is negative, which means that 12 watt of power was supplied. Fine. Now there is a method to also this to this. Now this visualization, I feel that this is fail proof. But for faster calculations, this is a two-step approach, right? You have to first reverse the current, then write it as, like, I mean, that's 4 into minus 3. So it requires two steps in even in your brain, so it might consume a little more time. So if you want to do, if you have once you have understood this concept very well, you can go for this second method, which is a very fast method. But if you are getting confused in the concept, again go back to this particular first method. This is you cannot fail through this method, absolutely. Now any current leaving the positive terminal will be treated as negative by default. For example, in this case, since the current was leaving the voltage source, now I will by default assume wherein P absorbed is equal to some 4 volts into minus 3 volt. I'll write it as minus 3 by default because it is exiting the positive terminal. Okay, fine. That is a second visualization. So you solve a couple of problems, and I will solve it. I'll solve in the next videos, and you will understand that this is a very easy concept. Fine. Now, from this concept, another concept that stems is sigma p is equal to 0. It comes from, it is derived from this particular uh, theorem, conservation of energy. Any energy supplied is equal to energy absorbed. Now this is again my terminology, I see. Now when you differentiate energy with respect to time, the P supplied is equal to P absorbed. That is sigma P is equal to 0 in a closed circuit. Now why I have written it as an IC is because it helps you to solve problems very fast. I will, okay, for example, I am given three elements. There is a circuit and I am given three elements. And I know the power consumed and supplied for two elements. So I need not calculate the voltage across the third particular element and calculate the current passing through the element and then write it as the product of Vi, then again check the sign convention whether it is applied or observed. I can simply do the algebra and it will give me the answer. That is why this is a very important concept. Now, this is the formal definition if you want. Energy. Energy is the capacity to do work measured in joules. E is equal to integral p dt from t naught to t. If power is supplied or absorbed, if power supplied or absorbed is constant with respect to time, then you can take it out of integration and it will be simply p delta t. It is the case generally in the especially in the base in this particular first chapter. The numericals are formed are in this particular form that you multiply the power with the time and you get the energy absorbed or supplied. Okay, so some important graphs that are important from from this particular chapter, that generally only Vi characteristics for certain elements are asked from this particular chapter. So Vi characteristics for a voltage source and for a current source. Now let's go back to the particular definition that voltage source is a device which maintains a constant potential through the two terminals across the two terminals regardless of the current passing through it, which is reflected here. That is V equal to constant. That is a graph. And current source, simply the opposite, that regardless of the potential, the current is going to be the same in that particular branch. And it is reflected in the straight line. I is equal to constant. Now resistor, specifically ohmic resistor. Now why I have written it as an ohmic resistor? Because in real life, practically speaking, not every resistor follows the Ohm's law. That is V equal to IR. Not every resistor follows it. So yeah, so only ohmic resistor follows the V equal to IR rule, and it is seen in this particular form. V equal to IR, the slope is R. Now these are two graphs that you may or may not be familiar with. Now short circuit, let's understand these two terms, open circuit and short circuit. An open circuit, an electrical circuit with impedance tending to infinity. You can see here that the resist you may already be familiar with Z, that is impedance, that is x square plus r square and the root. You may be already familiar with this, but even if you are not, you can understand it again in the AC section. Right now just treat it as r tending to infinity. So the resistance or impedance is tending to infinity in this particular section. So therefore no current will pass through this particular portion. Okay, and for example, capacitor at t tends to infinity, that is a circuit, it is an open circuit. Now short circuit, you as you can see, it's an electrical circuit with impedance tending to 0. You can see in this particular branch that all the current will flow through this particular this branch because the resistance is tending to 0. No current will flow through this particular branch. And you can see that you may already be knowing this particular concept that inductor at t tends to infinity is a short circuit. So anyways, you will learn that in the next couple of chapters. Yeah, so let's move back to these graphs. Now once you have understood a short circuit, you understood that no matter whatever the potential across this is, the current is going to be 0. The potential across this is potential across this, right? So even no matter what the potential across this is, the current is gonna be 0 through this particular branch, and it is reflected in this graph. Open circuit, now in the same analogy is that open circuit, like whatever is the potential across this, regardless the current is in the I mean whatever is the current across this, the potential is going to be 0. Potential here means a potential difference. This may be at a, like at 4 volts, this, then it means that this is also at 4 volts. That is the point. So yeah, I think I've covered all the basics pretty much in this particular video. From the next video, I will solve the particular problems. I say this first chapter does not have any much like difficult concepts. Only the new concepts will be this voltage source, current source, and this active and passive sign convention. And I will solve up, some questions regarding that. And yeah, so that is the flow of this particular course, that the first video is going to be lecture video. I'm going to give you the notes in the description. And yeah, the next videos will be the solving videos. Okay, so hope you guys like this session, and I will see you in the next video. Thank you.